Hello, in this question we're looking at the formation of stationary waves. This was generally well answered, but those who didn't score highly, it was more of a quirk of the mark scheme rather than anything else. So we're just going to quickly look at how we answer this question, and then we'll see what the mark scheme says. Handily, they've given us 3 bullet points, which should help you formulate your answer. But first of all, we want to say, how are stationary waves formed? Well, they are formed by 2 waves, and importantly, these waves are traveling in opposite directions. So you might have one wave traveling left to right. It is incident upon a surface, and then this wave is reflected in the opposite direction, and so it moves this way here. Now, that's the first thing. So we want to say something about its reflection, traveling in opposite directions. The 2 waves meet, they overlap, they interact, they pass through each other, they cross, whatever. Just that they go through one another, some indicating that point there, and there are 2 waves traveling opposite directions. Now, an important thing about this is that they are of the same wavelength or frequency. You cannot have a stationary wave unless these 2 things are satisfied. Traveling in opposite directions and same wavelength and frequency. So the second thing is features of a stationary wave. Well, what we can do is we can just draw this again a little bit bigger. So we have one wave traveling one way, which is going to be our red line, and then obviously in the opposite way. Now, at these positions here, here, and here, we have our nodes. And you want to say that these are positions with minimum minimum displacement. So minimum to no displacement, no disturbance, something along those lines there. And the second thing we want to say is we've got positions of, and these are called antinodes. And these are positions of maximum displacement, where they are displaced the most. Now, we want to do the third bullet point, which is a description of the process that produces these. Well, for the nodes, we want to say that as the waves travel, at those positions there, those 3 positions, those 3 nodes, this is where the 2 waves cancel, or they destructively interfere. You could mention about their phase difference is 180 degrees. They're in antiphase. So at all points at those 3 positions, these 2 waves traveling in opposite directions are always destructively interfering in such a way that they cancel out to 0. Of course, they're interfering the entire way along, and so their amplitudes are adding at each position of this wave. But in those 3 positions, there is a special case where they are 180 degrees out of phase, antiphase, however you want to word it, and therefore a peak and a trough, or some amplitude and minus, or some displacement and negative displacement meet to cancel out. In the center, we have positions where these are antinodes, and at these positions, they reinforce, they constructively interfere, and so their displacements add together to give this maximum amplitude. You want to mention superposition of these 2 waves. That is essentially the phenomenon which is going on here. And lastly, you can say something about the energy. Is energy transferred in this? No, it's not. Energy is not transferred. Now, why is that? Well, in a normal transverse wave, it's a traveling wave, progressive wave, it travels in one direction, and therefore the energy moves like this. But in this, we don't have these antinodes moving from left to right. In the progressive wave, we do, but in the stationary wave, we don't. So what happens with these nodes, with these antinodes? Well, the antinodes oscillate up and down. They move like this. And so to get the 6 marks, you want to say everything we've talked about so far. So the waves traveling in opposite directions, same wavelength, same frequency, give a description of nodes and antinodes, what they are, how they're formed. But lastly, you want to mention with the antinodes that they oscillate up and down. You need to mention something to that nature. Okay, let's look at the mark scheme. So this is what we need to say for each thing. I've kind of taken the mark scheme and butchered it around the place. And I'll just explain the little marks here. These are the max marks which you can get for each bit. So if you only got 1 mark, you really only said 1 relevant point. 2 marks, 2 relevant points. 3 marks, 3 relevant points. But now we get on to where it gets a bit tricky. So you might have said everything here, but if you did not say 1 and 2, so if you did not say this and this, you couldn't get any more than 4 marks. So you need to say both those things. You need to say that the waves reflect, they interact, and that they're the same wavelength or frequency to get 5 and 6 at least. So you got 4 marks if you said one of these things plus any 3 others. To get 5 and 6, as I say, we need to say 1 and 2 plus any 3 others. For 6 marks, as I've said, we need to talk about this, point number 4, where they're oscillating. It's this idea the antinodes are oscillating.